Hi, welcome back. Today we're going to talk about describing energy. So first of all, we need to talk about what is energy. Energy is the ability to cause change. So in other words, without energy, nothing would ever change. In order to understand this concept, the next thing we need to talk about is what is work. To go any further, I'd like to introduce the concept of work. The topic of energy will make much more sense later with this knowledge. Work is the transfer of energy when a force is applied over a distance, and work is measured in joules. So waking up in the morning and brushing your teeth takes work. Writing notes in class takes work. And carrying your backpack down the hall also takes work. We'll refer back to these pieces in a little bit. Moving on, last lecture we talked about different forms of energy. Now we're going to talk about how those specific types of energy are categorized. Those categories are called kinetic energy versus potential energy. In order to explain this concept, let's go through the terms first. Have you ever had a teacher or a parent tell you, "Hey Johnny, you have so much potential"? What that means is you have the capacity to become something or do something. Potential energy is just like that. Potential energy is stored due to the interactions between objects. Potential does not involve movement. Let's take a look at the girl in the picture. She's holding a ball over what looks like a cliff. What could happen with that? She could potentially drop it and transfer a lot of energy. That's right. Now, how about kinetic? The way I like to remember this is to think about those crazy K'Nex toys. When you buy K'Nex sets, they give you a plan to create some sort of structure, most of which can move in one way or another. I've used the K'Nex to create rotating Ferris wheels, like the one you see in the picture, to a DNA helix that I could unwind. Anyhow, how does this relate to kinetic energy? So I use the K'Nex to help remind me that when kinetic energy is, it's because kinetic energy is moving. So it's the energy due to movement or due to motion. When you look at the girl in the right side of the picture, she has dropped the ball and has therefore converted that potential energy into kinetic energy. We can categorize all the forms of energy we discussed last lecture into potential or kinetic. Types of potential energy are chemical, nuclear, stored mechanical. Types of kinetic are sound, radiant, electrical, and thermal. Do you understand why these are categorized this way? That's right. If you think about chemical, atomic, and stored mechanical, they're not changing at any particular point. They're really holding on to all that energy until they're converted into another type. Kinetic energies like sound, radiant, electrical, and thermal are all dealing with some sort of movement, whether it's through waves or just atoms moving around. Kinetic energy from an object's motion depends on that object's mass and speed. Its relatively simple equation is Ke equals 1/2 times m times v squared. So m is our mass and v is going to be velocity. And Ke is going to be your kinetic energy. Remember, whenever we do any sort of math problem, we always want to use the guess method. G is for givens, U is for unknown, E is for equation, S is for substitution, and the other S is for solution. Let's try this problem out. It reads, how much kinetic energy is generated when a 5 kilogram cart is speeding down a hill with a velocity of 5 meters per second? We don't know our Ke, but we do know m is 5 kilograms and v is 5 meters per second. Now write out your equation. Ke equals 1/2 mv squared. Now we'll substitute in everything we know. M is 5 kilograms and V is 5 meters per second, and we're going to quantity that and square it. Now you must put this into your calculator carefully. If you have a graphing calculator, take advantage of the parentheses. If you don't have parentheses with your calculator, you might want to break this down into pieces. Go ahead and square your velocity first. 5 to the second should give you 25. Now multiply that by 5 for the kilograms and hit enter. Lastly, multiply this by 1/2 or by 0.5. You should come up with 62.5 joules. Ah, those joules. We must have done work in order to show this energy. No pun intended. This is the time when those algebra skills and remembering the order of operations really comes into effect. You may want to review the order of operations and how to use your calculator on your own. What about potential energy? We talked a little about it before, but I'll explain it further. Potential energy has 3 types. There's elastic potential energy, chemical potential energy, and gravitational potential energy. Elastic potential energy is energy that is stored by compressing or stretching out an object. A great example of this is when you stretch a rubber band and let it go. It sails across the room. Chemical potential energy is the energy that's due to chemical bonds. For instance, the food that you eat and the gasoline in cars have stored energy that can be released, energy that is due to the gravitational force between objects. Gravitational potential energy is often shortened to GPE. An apple attached to a tree has gravitational potential energy. The apple has the potential to fall off the branch when it's ripened, and when it does, gravity will pull it towards the earth. The GPE will also depend on what height the apple's at. Let's expand on that. So mathematically, the idea of GPE can be explained by this equation. Gravitational potential energy, which is in joules, mass, which is equal to mass, which is a kilogram, and gravity, which is, we'll probably use meters per second squared, or you could say newtons per kilogram, times that height, which is in meters. So GPE equals mgh. Let's try it out. A 4-kilogram ceiling fan is placed 2.5 meters above the floor. What is the gravitational potential energy of Earth? The ceiling fan system relative to the floor. Start by listing your unknowns and givens. GPE is unknown. M is 4 kilograms. G is 9.8 meters per second squared, or newtons per kilogram. And H is 2.5 meters. Write out your equation, GPE equals mgh, and substitute in 4 for m, 9.8 for g, and 2.5 for h. Go ahead and plug that into your calculator, and you should get 98. Notice your kilograms units will cancel, leaving you with n times m, which is also known as J for joules. It might be easier at this point just to remember that all energy that we will use will be using the unit joules. Before we finish, we need to be able to identify potential and kinetic energy on a diagram. This is very important, and we'll work more on this in class. You should also visit the videos listed on our class course site for further explanation. So here we have the infamous roller coaster example. If you look at the roller coaster starting on the left, you can see at the top of the hill they have 0 kinetic and all potential, which makes sense because that person has great potential to move down that hill. Next, mid-hill, they have kinetic energy of 50 and potential energy of 50. They could potentially move back down, but they will also have motion pushing up on them. As they dip down the hill, they lose all of their potential and gain kinetic, which makes sense. There's no more potential to move down here, but they do have motion. Next, the person begins to climb the mini hill. In the last segment, the person has a kinetic energy of 75 and a potential energy of 25. A lot of motion still, but a little potential to move down. Take a look at this pendulum. Here we can see the different levels of the pendulum as well as the direction it moves. If you look at the left side, you can see the highest point of the pendulum swing. When it moves to the middle, it has a maximum kinetic energy and a minimum gravitational potential energy. Finally, as the pendulum moves to the right, there is no more kinetic energy, but a maximum gravitational potential energy. This is much easier to view and understand the change of kinetic and potential with animated objects. Remember to check out those videos on our course site. That's all for this lecture. If you need additional help, please review the video again or refer to our text. And we'll see you next time.